So while we were filming the GC method of element Demystified, we ran into a real problem. By the way, you can catch that video description down below, has the link. So the problem we ran into is that some of our peaks were tailing, but some of our peaks looked beautiful. Anytime you have some peaks tailing and the other ones look good, that means column insulation is good. That's validated by a single symmetrical peak, but we must have a problem with adsorption. There's dirt somewhere in the instrument, and most likely the dirt's going to be in the liner. So watch me hop into this GC. We're going to pull out the liner, put in a new one, the column, drop in a new gold seal, and it's going to fix the problem. So what I'm going to do is I'm going to pull out the liner and drop in a new one. Now, officially, the official way to do this is we would cool down the injection port. It's at 250 degrees right now. We'd cool down the column. We'd have the whole thing cool. We'd do all this, and we'd heat everything back up. But that's going to take me another 30 or 40 minutes. So I'm going to do it while it's hot. The whole trick here is we don't want the column hot with no flow. So fortunately, my column temperature, actually I'll take it down to 40 degrees, so the column itself is not very hot, and when it loses flow, when I pop open the liner, there's going to be no flow going through the column, and if I do it fairly quickly, I'm not going to do much damage. I wouldn't do this and then walk away and take a coffee break and then come back a half an hour later, because you don't want the column to ever be heated with no flow, but we're going to do it hopefully quickly enough that it's not going to make a big difference. So to take out the liner, I'm just going to remove my sample so it doesn't spill. I'm going to pull this off. I'm just going to set it on the side. That allows me to open up this top, puts me in a little better position when I'm going to open the liner. Now, since this whole thing is hot, since my injection port is currently sitting at 250 degrees Celsius, I don't know, what is that, 450 Fahrenheit? I'm going to put on some cotton gloves so I don't burn my little fingers, or a better way to put it, I'm still going to burn my fingers. It just won't hurt as much. So my next point is to open this up. There's a little slider, and I'm going to slide this open this up, pull this guy out, and here we can see our old liner, and now I'm going to pop a new one in. Put on a new O-ring. So I'm going to drop a new one in. Go back here. There we go. So it was only down without flow for a few seconds, and the temperature's not terribly hot. And when I take a look at the liner itself, at first I'll say nothing's jumping out at me, but I'll let you take a look at it as well. We can see, let me step out of the way here, and if you look at the glass wool, sorry, don't touch it, it started burning my finger. Okay, that's going to be much better than. So if you look at the glass wool, I think you probably see a little dirt inside there. So I always look at the glass wool and then also look down towards the bottom to see if there's any graphite swimming around down there. A little graphite, a piece of the ferrule can make it down there and cause adsorption and tailing issues. So in real life, you often cannot see the problem if it's there. We could only see it by looking at the tailing peaks. So now let's go back to the GC and see if this made any difference. Put our auto sampler back on. Put my sample back in. We'll come back over here. And I'm going to turn the oven back up to 100 degrees. So the GC is just now coming up to temperature. I'm going to go to run control, sample info, and this time I'm going to say new column, or new liner. And we'll leave all the other conditions the same. And we'll start the run. Now this is a liner, I'll call it a new liner. probably not brand new, it's probably something we've cleaned before. But it's been sitting around, I may have touched it with my fingers, so I wouldn't be surprised, the very first injection, to get some extra stray peaks, extra ghost peaks here and there. To do this properly, I should heat it up, make an injection, throw away that injection. But I figure if I'm going to inject something, I might as well inject a sample so I can see whether or not the alcohols are tailing. So here's the GC getting ready. It's setting the flows, and so there's our injection. We reset the clock to 0. So that's the 10th peak. Okay, so our little fix seems to have worked. If you remember what happened, we were running the sample that had the alcohols in it. The 2 alcohols were giving tails, and I see a lot of peaks, and right away it jumped out at me that it's tailing. But if it doesn't jump out at you, that's okay. Eventually it will. But if you look at the output, I'm using what's called a performance report in the Agilent systems, and not only does it give me resolutions, which we've been looking at, but it also gives us symmetries. So this is the one that we just ran, and if you notice the symmetries, 1.0 is a perfect peak. So that's our solvent front. So we're up here at 106, 0.9, 10, 0.89, 0.98, 0.84, 0.99, 0.97, 0.95. The 2 worst ones are the 8.4 and the 8.9. Those are our alcohols. Now, let's see what they looked like before. So we're going to go over to data analysis, and we're going to go back to our calibrated column. I think this is the one we ran. Yeah. So clearly looking at it, we know it looks a lot worse than what we're dealing with right now. But if I tell it to go ahead and show me the report, it will show me the report on the screen. And again, we get the lousy looking chromatograms, but let's look at our symmetries. Remember, they're supposed to be close to 1. So we got 97, 10, 10, 47, 93, 42. Those are horrendous. Those are the alcohols. 93, 89, 88. So that's what we started with. And when we changed the liner, we went to this. So right away, just looking at it, you could tell they're much more symmetrical. But let's look at the actual numbers. And we went from our 0.42 and 0.43 numbers up to numbers that are now 0.89. 0.84, 0.89 are the worst ones. So huge improvement in the symmetry. Like I said, what I would do typically would be not only clean the liner, change the liner, but I'd change the gold seal, clean the gold seal, and chop off a little bit of column. That'll get that last little bit of tailing under control. So that is as practical as it gets. We are, during method development, we turn into troubleshooting because we see an issue with the peak shape. So as we continue down this path of demystifying GC method development, now it's time to look at a complex sample. This one, we go through all the standard method development approaches and nothing works. We end up with co-eluding peaks. And what do we do next? Now it's time to change the stationary phase. So check out the link below and watch me do a deep dive in method development where stationary phase doesn't work and it's time to try a new column. So let's go demystify.